To achieve maximum yield gold leaching rates, the use of highly toxic sodium cyanide is no longer a requirement. In this video, we are going to walk through a complete 30-day industrial heap leaching process. You will see exactly how to process raw ore into gold-loaded carbon using a safe, eco-friendly reagent. Before you begin the month-long cycle, you need two things in place: a flat stacking pad equipped with both pregnant and lean liquid pools, and a completed 30-kilogram small-scale lab test of your ore that confirms a recovery rate of around 85%. Proving that your specific ore is compatible with the reagent in the lab first is the only way to ensure your operation will be profitable and entirely cyanide-free at an industrial scale. Step 1 is physical construction. We need to build a 4,500-ton ore heap, starting with its protective foundation. This diagram illustrates the necessary leak prevention pad. It requires a specific sandwich structure: a bottom layer of polyethylene color stripe cloth, a solid film in the middle, and a top layer of polyethylene cloth to seal it. Once that base is secure, the crushed ore is stacked 3 meters high on top. During stacking, you must mix 14 tons of lime evenly into the pile, and then map out your surface spray devices across the crest. With the heap built, attention shifts to the lean liquid pool. This is where the eco-friendly reagent enters the system. For this initial mix, add exactly 200 kilograms of the reagent to the pool. This achieves a strict starting mass fraction of 0.028%. Now, activate the continuous spraying process. Set your flow intensity to exactly 15 cubic meters per hour. Combining that flawless pad architecture with an exact initial chemical saturation ensures the fluid stays in the system, preventing reagent waste and protecting the surrounding soil from contamination. Now that the sprayers are running, the core engine of the leaching operation takes over: the closed-loop percolation cycle. Look at this flowchart. The liquid percolates through the heap, picking up the extracted gold, and channels directly into the pregnant liquid pool. From there, the gold-rich liquid is pumped through activated carbon columns. These columns act as a filter, stripping the gold out and transforming the fluid back into a lean liquid. This lean liquid is then returned to the lean pool, topped up with additional reagent to maintain that initial concentration, and pumped back to the surface sprayers to repeat the cycle. Maintaining this loop requires daily monitoring. You must sample the liquid every day to ensure the carbon absorption rate never drops below 98%. The primary failure point in this stage is a complete stall of the leaching cycle, which will happen if the alkalinity drops too low. The graph here shows the required pH trajectory. It starts low at a pH of 8 to 9, but it must be forced up into an optimal 10 to 11.5 range by day 3. Treating this closed-loop system as a living organism and monitoring its pH as its vital pulse maintains your extraction momentum over the full month. Around day 16, natural diminishing returns will set in. You will see the gold mass concentration in the liquid drop below 0.06 grams per cubic meter. When that happens, completely suspend spraying. You must physically tear directly into the 4,500-ton pile to turn the ore over. This physical intervention is required to disrupt the fluid channels that naturally form over 2 weeks, which exposes hidden, unleached ore deep within the pile. Once the pile is turned, reinstall the surface sprayers, introduce a top-up dose of the eco-friendly reagent to the pool, and restart the cycle. Fast forward to day 30. This is the milestone for final evaluation and extraction. The dashboard metric that indicates the process is complete is the gold mass concentration firmly dropping below 0.03 grams per cubic meter. With that metric hit, shut down the sprayers. Extract the gold-loaded carbon from the columns and send it off to analyze its moisture content and overall grade. Without that aggressive mid-cycle physical turning on day 16, the fluid would have continued bypassing the hidden ore, sharply reducing this final harvest before smelting. The final industrial results of this 30-day cycle proved highly successful, achieving an actual gold recovery rate nearing 79%. This chart compares the two methods directly. The eco-reagent drastically lowers both operational chemical costs and deadly toxicity levels compared to traditional sodium cyanide. If you're an operator planning to transition to green facilities, source a certified eco-reagent immediately and initiate your own 30-kilogram lab test. Advanced eco-chemistry reduces overhead costs while eliminating hazardous ground contamination entirely. Adopting this safe 30-day cycle provides a strictly superior economic strategy for modern gold extraction.